Hi, grade 9 ICT students. This is your teacher Geraldine again, and welcome to another episode in Computer System Servicing. This is our second week, and our topic is about binary numbers. Last week, we already discussed the different measuring tools used in CSS. This time, our learning competency is about selecting appropriate measuring instrument to achieve required outcome. 2. Obtain accurate measurements for job. And 3. Perform calculation needed to complete task using the 4 mathematical fundamental operations. And for your guide questions, what is a binary digit and how do you convert decimal number to binary digit and vice versa? Before we proceed with our next lesson, let us first define the following terms. First, binary. It is the primary language for computers that is made up of only two numbers, 0 and 1. Binary prefix, used to represent the quantity in terms of byte or bit in computing. Decimal, a base 10 number system. Bit, or small letter b, is short for a binary digit, either 0 or 1. Byte, or capital letter B, is a unit of computer information consisting of 8 digits, or bits. Gigahertz is also known as clock rate or clock speed of the processor. Binary number. Again, when we say binary, it is a base 2 number system, and where the 2 number is raised by an exponent n minus 1. So as you can see here, so we have 2 as the base, and it has its exponents from 0 to 7, but it could be more. So if we are to recall in our math, any number raised to the power of 0 is equal to 1. Any number raised to the power of 1 is equal to its base, which is 2. 2 squared is same as 2 times 2, which is 4. 2 raised to the power of 3 is 2 times 2 times 2. 2 times 2 equals 4, times 2 equals 8. So if we are to continue to the 4th power, 2 times 2 times 2 times 2. So 2 times 2 equals 4, times 2 equals 8, times 2 equals 16. So that is how you do it, and it goes to the other numbers or other exponents. To read binary number, you need to get the turn-on values only and sum it up. So no need to include the turn-off values. So the turn-on values are the numbers with 1 as its value, while the turn-off values are the numbers with 0. So recall that our binary digit has two values, the 0 and 1. So again, 0 is turn off and 1 is turn on. So we are only to add the numbers with turn on values. So for our example here, so 0, 0, 0, 0, 0, and we have the last one. So meaning the turn on value is 1 only. Now for multiple values, here are our examples. So we have 1 as the value, and another 4 as turn on value. So 1 plus 4 is equal to 5, meaning the equivalent of 0, 0, 0, 0, 0, 1, 0, 1 is equal to 5. So for us humans, it's just simply 1 plus 2 equals 3. But for computers, it only consists of 0 and 1. Here, 1 plus 0 equals 1, 0 plus 1 equals 1, 0, and all. So note that each group of 8 bits is known as a byte. That is how the computer represented the letters and numbers and all the data that you can see in the computer, like images and videos. Now let's proceed with decimal to binary conversion. So our rule is if the fraction is 1/2 or 0.5, then it is equivalent to 1. In converting decimal number to binary, all you have to do is divide the number by 2, which is the first step. Next is to write the quotient and multiply the remainders by 2. Then divide the remainder by 2. Repeat the steps 2 and 3 until you get a quotient of 0. Then read the values of the remainder from the bottom to top. Write the values to get the binary value of the decimal number. Let us have here 19 as an example. So we are to convert number 19 to binary. So again, first step is to divide the number by 2. So 19 divided by 2 is equal to 9, and since 9 times 2 is equal to 18, we still have remainder 1. Then divide the quotient by 2 again. It is equal to 4, and it has a remainder 1. And then repeat the steps until you have the quotient 0. So 4 divided by 2 equals 2, no remainder. 2 divided by 2 is equal to 1, no remainder. And 1 divided by 2 is equal to 0, remainder 1. So we have reached the 0, and it's time for us to stop from here. And the last step is to copy the remainders from bottom to top. So it should be 10011. Take note that a byte has 8 binary digits. So add zeros from the left to complete the digits. The final answer is 19 is equal to 000100011. Now let's have our checking. So we have two methods. Let's start first with the method 1, which is the binary table. So first is to create a binary table and then input the binary value into the table properly. Each digit should be entered on the correct column starting from the right here to left. So our answer is 10011 here. So value, if you can remember, 16 plus 2 plus 1. Add the turn on values. It is equal to 19. For method 2 is the binary to decimal number conversion. So our step is to multiply the bits with its corresponding value, and take note to always start from the right, then get the sum. So we have 1 times 1 plus 1 times 2 plus 0 times 4, 0 times 8. For you to do this easier, so just disregard these numbers with 0 or turn off values. So then we have 1 plus 2 plus 16, still equal to 19. So again, 19 is equal to 00010011. Alright, so we're done with binary digits and binary digit conversion. So what have you learned today? So of course, we learned that binary digit is the primary language for computers that is made up of only two numbers, the 0 and 1. It It is a base 2 number system where the two numbers, or mean number 2, is raised by an exponent n minus 1. So in converting a decimal number to binary, all you have to do is to follow the steps. First, divide the number by 2. Second is to write the quotient and multiply the remainder by 2. Next, divide the remainder by 2. Then, repeat steps 2 and 3 until you get a quotient of 0. And last step is to read the values of the remainder from the bottom to top. Write the values to get the binary value of the decimal number. So there are also two ways to check if the conversion is accurate. Method 1 is using the binary table, and method 2 is binary to decimal conversion. Well, it's now time for your activities. So in your week 2 last 2 carry out measurements and calculations, you may now accomplish activity 1 and activity 2 on page 4, as well as the reflection also on page 4. Once done, you may send it offline using USB or online through Messenger or email. This is your teacher again, Teacher Geraldine, and see you next week. Goodbye.